Hello and welcome to our next lesson. It's Mr. Cockrell here. Great to see you all again. I hope you've been enjoying doing some online content or lectures. And today we'll be talking about a great topic because it explains so much about how atoms really interact with each other. So we are talking about electron shells, and in particular, we're just going to touch quickly on their orbitals. So, electron shells are a way of organizing and modeling where electrons, or E- as we represent them as, are located around a nucleus. Electrons like to fill shells from the closest to the nucleus further out. So if we look at our lithium atom over here, we have our nucleus in the center, and then electrons would fill that first shell with their first electron and then second electron, because it still has space before filling the second shell. And this comes down to orbitals, which we'll discuss in a second. So, electrons have a spin associated with them. We write them as this little up arrow and down arrow, and these represent a positive and negative spin. And that is the reason why they pair up. This first shell, they do sit opposite, but every time after this, they always sit in pairs. Cool. So, shells are determined by orbitals, which is where we are most likely to find electrons. Orbitals require a certain amount of energy in order for an electron to occupy it, and hence why they fill from the inside, which have the lowest amount of energy required, to outside it. And if you think of a magnet, the further away you get from two north ends of a magnet, the weaker that connection is. So, when we're talking about electron shells and filling them, we really do have to remember that all atoms have an ability to have all the shells. It's just that they aren't filled, so we don't often represent them if they don't have electrons in it. So, if we're looking at this particular atom here, we have the nucleus in the center with our protons, plus, and neutrons, which are a neutral charge. We should remember this. In our first shell here, this fits 2 electrons. And funny enough, if you look at our periodic table, our rows on our periodic table, there's 2 elements in our first row. Cool? So these 2 electrons are both negative charged, so just like a magnet, north and north, they do want to repel each other. So they'll be opposite there. Next, in our second shell, this is where we can fit 8 electrons. And so this is all determined experimentally, because we can kind of force an electron to go into one of these orbitals or shells, and it just requires a lot more energy to add a 9th one or to take away a 7th one. So therefore we know it must be 8 in this shell. So I've slightly stuffed up when putting these electrons around. I should have put 1 in each of the 4 positions first, because as we said before, electrons do have a spin associated with them, which means that they do like to pair up. But they are also negative charges still. So they'll repel each other first. So you'll put 1 electron in each position first, and then start to pair them up until you get to 8 electrons. Cool. And in our third shell here, this is the exact same. So the third shell can fit 8 electrons, and once again, it is determined experimentally, and you'd fill from each of the 4 positions first, and then start to pair them up. Perfect. Thank you so much for listening. We'll see you all in class. Bye.
I just blew my mind.